Let's have a look at like terms. So in order for something to be a like term, it has to have the same letter variables and the exact same powers. Okay, the coefficients of those are allowed to be different. If they have the same, that's fine. If they're different, that's fine. But the letters, all of the letters must be the same, and the powers matching those letters must be the same. So for example, we've got here 3a and 2a. They both have the same letter A, and they both have that power of 1. We're lazy, we don't write the 1, but it's implied. So because they've got the same letter and the same power, that means they are like terms. The coefficient is different, so this one's got a coefficient of 3, this one's got a coefficient of 2. Different coefficients, but the terms are like terms. There's some examples just underneath now. If I look at these other ones here, okay, so these ones here, we want to decide, are they like terms or not like terms? So the key is looking for the variable and matching power. So this has got a d squared, d squared, d squared, d squared. So they've all got a d squared in it. It's also, there's an e and an e and an e and an e. So that means that combination, d squared e, d squared e, d squared e, d squared e, that combination is the same. The difference is the coefficients, but apart from that, the rest of it is the same, so that means these are like terms. What do we need to do with like terms? Well, let's think about this. If I've got some blocks of 6 that I'm combining together, that's the same as saying 6 plus 6 plus 6 plus 6 plus 6. They're all blocks of 6, so they're all like terms because they're all the same. And now I'm just combining them together, so I've got 5 lots of 6, which I can write as 5 times 6, or I can just add them all together, and that goes to a value of 30. The one below that, I've got a block of a D, plus I've got a D, plus I've got another D, plus I've got another D, plus I've got another D. So how many blocks of D are there? Well, there's 1, 2, 3, 4, 5 blocks, so there's 5 lots of D. And so I can also write that as 5D. I can just take out that times sign. Okay, it just means, so when I say 5D, it means I've got 5 lots of D, whatever the number D might be. Some simplifying examples here. So 7 times A, like the previous one, I can just remove that times and write that as 7A. Just remember though, in the background, 7 times A is the same as adding 7 lots of A. Okay, it means the same thing. 1, 2, 3, 4, 5, 6, 7. So that means the same thing. 1 times Y, this is when I'm often lazy. If I just write letter Y and I don't put the 1 in front, it's assumed that we know that it means that there's a 1 in front. So we're just being lazy. But Y is the same as 1Y, which is the same as 1 times Y. They all mean the same thing. Let's have a look at this one. So I've got A plus A plus A plus 7. So think about that visually. I've got one block of A, I've got another block of A, I've got another block of A, so I've got 3 blocks of A. So that's the first part I can do, is I can say, well, I've got 3 blocks of A, and I've got a block of 7. Now I can't combine the A's and the 7's together, so that is not going to become 10A or anything like that. The 3A and the 7 are separate terms. They're not like terms, so that we need to keep them separated. These two here, 3x plus 2x. The first question we have is, are these like terms? So this is x to the power of 1, this is x to the power of 1, so they are like terms. And so we can see on the diagram below, if I'm adding 3 lots of x's plus another 2 lots of x's, overall that's going to give me 5 lots of x.